Hi guys, today we're going to solve another fuel combustion problem, and this time we will base our calculation on the partial analysis of the flue gas. So if you watch our previous video, you will see that in that problem, the complete Orsat analysis of our flue gas is given. So we based our calculation from that Orsat analysis, but on this problem, we will have just a partial of information sa ating Orsat analysis. So let us start by reading our problem here. The burning of pure butane with excess air gives a stack gas which analyzes 11.55% of carbon dioxide on a dry basis. Assuming complete combustion, calculate A. Percent excess air and B. Complete Orsat analysis of the stack gas. So as you can see, our given here is a fuel consisting of pure butane. So that means our fuel here is C4H10. Alright. And then we have excess air. Okay, so we are providing with excess of air. Okay, so yan ang mga given natin. Now, it gives a stack gas which analyzes 11.55% of CO2. So we have CO2 which is 11.55% on a dry basis. So that means on this analysis, water is excluded because this is dry basis. And alam natin that if we have dry basis or if we did not include water in our analysis, that is Orsat analysis. So we have a partial Orsat analysis in our stack gas. Now, assuming complete combustion, we need to find percent excess air and complete Orsat analysis of the stack gas. So we're going to start solving the percent excess air. Alright, so to begin, we need to have a basis. Okay, so I'm going to use our fuel as our basis. Okay, so let me have a basis of 100 gram mole of C4H10. Okay, so we know that in here we have 100 gram mole. Okay, so since we are looking for percent excess air, so that means it just makes sense na dapat alam natin kung gaano karami yung ating theoretical O2. Okay? Para makuha natin kung gaano karami yung excess O2. So, we need to determine the theoretical O2 first. So, what is the theoretical oxygen? So, this is the amount of oxygen needed to have complete combustion. Diba? So, take note that our given here states that we have a complete combustion. Ano? So, it is clearly stated here that for this problem, we have a complete combustion. Okay, so we have our reaction for combustion. We have C4H10 plus O2 producing CO2 plus water. So this is because we have a complete combustion. So ito lang yung ating reaction. And in fact, we can assume that in our stack gas, we do not have carbon monoxide because we have complete combustion, and we know that nagkakaroon lang tayo ng carbon monoxide if we have incomplete combustion. Therefore, so what other components do we expect to have in our stack gas if we have a complete combustion? So we will not have carbon monoxide. So we will be expecting excess oxygen, right? So therefore, we will have excess O2 here. So we have O2 in our stack gas. So that will be our excess O2 that we need to determine in here, no, in our A. And what else do we expect to have in our stack gas? We expect to have nitrogen here, N2. Okay, and we can only determine how much nitrogen we have in our stack gas once we got how much is our air supply. Okay, alright, so let us start here. We know that we have 100 gram mole of C4H10 based from our basis. Okay, so we need first to balance our reaction. So we have 4 carbon. So we have 4 in here. Then next is to balance the hydrogen. We have 10 hydrogen here, so we need 5 in here. So how much oxygen do we have? We have 8 in here. 4 times 2 will be 8 plus 5 in here. So that means we have 13. So therefore in here we have 13 over 2. Alright. So how much oxygen is needed for complete combustion of C4H10? So let us try to calculate that. So we have 100 times 13 divided by 2, which is 650. So we need 650 gram mole of oxygen in order to have a complete combustion of C4H10. So therefore, our theoretical O2 is equal to 650 gram mole. So, alam na natin kung gaano karaming theoretical O2 natin. Alright, so how are we going to determine the amount of oxygen that we supplied? Okay, so we know now that we have 650 gram mole of O2 needed for complete combustion. But because we supplied excess air, so alam natin that we will have amount of air or O2 supplied more than 650 gram mole. So our O2 supplied from air, okay? So we have to take note that this O2 supplied is coming from air. So this will be 650 gram mole from theoretical O2 plus the amount of our excess O2, right? So let me assume, or let me assign, let X is equal to the excess O2 para mas mapadali yung ating calculation. So we will have 650 plus X. Okay? So that will be our O2 supplied. Now, if we know the O2 supplied, I mean the equation for our O2 supplied, so that means we can also determine the amount of N2 from air. Alright? That will be 650 plus X, which is the amount of oxygen in the air, multiplied to the ratio of nitrogen and oxygen. Okay? So nitrogen is 79 and our oxygen is 21. Okay? So this will be our equation for the nitrogen on air. Okay? And we know that all of the oxygen or theoretical oxygen that we have will be consumed in order to produce carbon dioxide. Okay, so that means our excess, which is X, which is our excess O2, will be the oxygen that we have in our stock gas. So O2 in stock gas is equal to X. Okay? So, let me write that here para meron tayong guide. Okay? So, let me write here our O2 in our stock gas is equal to X. Okay, so, ang magiging hint natin dito on how to proceed with this problem is itong ating carbon dioxide. Because as you can see, ito lang naman yung given na ang ating percentage. So that means if we determine how much carbon dioxide we have in our stock gas, we will be able to determine the number of moles of our stock gas, right? So, how much carbon dioxide do we have in our stock gas? Of course, since we have complete combustion, that means all of our butane are converted to carbon dioxide. So, if we have 100 C4H10, and our ratio is 4:1. So that means we have 400 gram moles of carbon dioxide, right? So, if we have 400 gram moles of carbon dioxide, which is produced na nandito sa ating stock gas, so that means 11.55% of the stock gas is equal to the 400 gram mole of CO2 in here, no? So let me identify our stack gas as dry stack gas, so that when we calculate, we will assign DSG as dry stack gas, the number of gram mole of our stack gas. So our dry stack gas is DSG. So in order to identify it properly. Alright. Now, we know from here that 11.55% of the dry stack gas is the CO2. So we have 11.55, which is 0.1155 of the dry stack gas is equal to the number of gram mole of O2, CO2 in our stack gas, which is 400. Okay, so we have here 400. So therefore, our dry stack gas is equal to 400 divided by 0.1155. So our DSG is equal to, let's use our calculator. We have 400 divided by 0.1155, which is 3,463.2. 3,463.2 gram mole. Okay? So, let me write that in here para mas madali natin siyang ma-analyze. So, we have dry stack gas is equal to 3,463.2 gram mole. Alright. So, here we know that our CO2 is equal to 400 gram mole. So, our O2 is X and our N2 is still unknown, but we have our equation in here. Our N2 is 650 plus X times 79 over 21. So, let me change this. Okay? Para maipakita ko sa inyo. How did we arrive to that equation? Na ipapakita ko. So, we have 650. So, we have 650 plus X times 79 over 21. Alright? So, if I'm going to add all of this, 400 plus X plus 650 plus X times 79 over 21, since these are the number of moles ng ating mga components dito sa stack gas, that means it will be equal to 3,463.2 gram mole. Right? So, we will have our dry stack gas balance. So, we have dry stack gas balance. Okay? So, we have, of course, we will have the number of mole of our dry stack gas is equal to the number of mole of our CO2 in our stack gas plus the number of mole of our excess O2 in our stack gas plus the number of mole of our N2 in our stack gas. Right? So, we know that our DSG is equal to 3,463.2. The number of gram mole of our CO2 is equal to 400. Okay? We already wrote that here. 400. Okay? So, 400 plus our O2 in our stack gas. This is our excess O2 and we assigned X for that. Plus our N2 in our stack gas, which is equal to 650 plus X times 79 over 21. Okay, so we'll do that here. We have 650 plus X times 79 over 21. Okay, so as you can see, we only have one variable here, which is X. Okay, and this is our excess O2. So that means if we calculate for the value of X in here, we'll be able to determine yung ating requirement A, which is the percent excess air. Okay, so let us solve for the value of X. Okay, so let me transpose 400 to the left side, so we will have 3063.2. We will subtract 400 here. Alright? So, we have here x plus, now, 79 over 21, para hindi tayo mahirapan, kunin na natin yung ratio niya in decimal form, which is 3.762. Okay, so 3.762. Okay, para may distribute na natin siya. So, 3.762 times 650, which is 2,445.24. Tama ba? Let me just confirm. Alright. So, in here we have plus 3.762x. Okay? So, we just distributed that here. Okay? So, now we have 3,063.2 minus 2,445.24. So, I just transpose that to the left side. Is equal to 3.762 plus 1, which is 4.762x. Okay? So, now, let us just solve this. We have 3,063.2 minus our previous answer, which is 617.962. Okay, 617.962. Okay, is equal to 4.762x. So that means our x is equal to 617.962 over 4.762. Okay, so our x will be equal to, so let me have our calculator again, divided by 4.762, which is equal to 129.77. Okay, so from here we are able to determine the number of moles of our excess O2 because we assign X as our excess O2. So that means our excess O2 is equal to 129.77 gram mole. And our requirement is to determine the percent excess air or the percent excess O2. Okay? So the percent excess O2 is equal to our excess O2 over our theoretical O2 times 100. Alright, so let us just substitute our values. So we have our excess O2, 129.77 gram mole over our theoretical O2. Ano nga yung theoretical O2 natin? Our theoretical O2 is 650 gram mole. Okay, so we have 650 gram mole times 100. This is cancelled. Alright, so our excess O2 percent excess O2 is equal to 129.76 divided by 650 times 100. So we have 19.96%. Alright, so this is our final answer for our requirement A. Okay, so now we need to determine the complete Orsat analysis. So as you can see in here, we already know the value of our excess O2, which is 129.77 gram mole. But we still don't know the value of N2. But we can determine that by substituting X to this equation, diba? So let us first identify the value of N2. Okay, so, alright, so the value of our N2 is equal to 650 plus X times 79 over 21. So we're just going to substitute the value of our excess air, which is 129.77, right? So we have our N2 is equal to 650 plus, what's again 129.77, 129.77 times 79 over 21. So our N2 is equal to, let's have our calculator. We have 650 plus 129.77 times 79 divided by 21. So we have 2,933.42. Tama ba? So, let me verify. 42, yes. So, we have gram mole of N2. Okay, so now we will have our complete Orsat analysis dahil alam na natin yung mga values natin. So, we have our Orsat analysis in here. Okay, so we know we have 3 components in our Orsat. We have our CO2, our excess O2, and our N2. Okay, so, and we know also that this is equal to a total of, where did we get that? Our dry stack gas, which is 3,463.2. So this is 3,463.2 gram mole. Right, so for our CO2, we already know that from here. Our CO2 is 400 gram mole. Okay, so we have here 400 gram mole. And we know that this is 11.55%. Okay, so alam na natin yan sa given pa lang. Our O2 is, our excess O2, 129.77 gram mole. So we need to get the percentage of that. And our N2 is 2,933.42 gram mole. So we need to determine the percentage. So how much percent O2 do we have? 129.77 divided by the gram mole of our stack gas, which is 3,463.2 times 100 is equal to 3.75. Okay, so 3.75%. And for our N2, we have 2,933.42 divided by 3,463.2 times 100. So we have 84.7. So we have 84.7%. So as you can see, we completed our Orsat analysis. So we finished solving the problem because this is the second requirement. Okay, so thank you for watching, and I hope you learned from this video and you find it really useful sa inyong pag-aaral in chemical engineering calculations. So thank you very much and have a nice day. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.